I'm going to do a 5-second summary real fast for viewers at home. We're going to go back here. Hi. I'm going to recap. Imagine you have a CSV file like this. That's bad. You don't want it that way. You want it this way, in which you have last name and then first name. And what we're going to do is we're going to use regular expressions for that. It's a way of manipulating text files, just in case anyone's listening. Is everyone here, by the way? No. No, not everyone's here, so I definitely need to do this. You're right. I see people missing. Actually, I don't see people. That's what tells me they're missing, not I see people missing. Whatever. Okay, so regular expressions is this way of manipulating text files, and manipulating text files is one of the most common tasks you're going to have. Doing data analysis throughout, if you do much data analysis after this point, it's something that comes up over and over and over again. Regular expressions is the search and replace language that makes it much easier. So essentially, like I said, it's a search and replace, but kind of on computer steroids. I made it very clear that those are not normal steroids as I went through. I just want to make that clear. And then how this is different than normal search and replace is that we're searching and replacing based on patterns instead of exact matches. So we can search and get lots of different text that matches what we're searching for, and then we can replace with part of our search result. We can use what we found as part of the replacement. Okay, now I'm basically back up to where I was. That was a good summary, right? Did I leave anything out? Okay, so wildcards, again, these special characters that you can use in a search that will not match exactly what they are, but they'll match a range of things instead of one particular thing. And we're going to use combinations of these wildcards to match a pattern that we're finding in the text, not just one individual thing. And then what regular expressions do provides you with a rich set of these wildcards, but also then customizable wildcards as well, so you can end up matching just about anything that you want. One thing that I do want to mention is this isn't a lot of text editors implement regular expressions. You can use regular expressions in a lot of text editors, but this type of search and replace has been implemented in basically everything. Most programming languages, Linux Bash, so like in the Linux shell, you can end up using it as well. You can use it in R. It's actually implemented in R as the commands grep, which is actually the same thing as what's called in Linux Bash, which will search based on something. And then this will just pull out stuff, and then if you want to replace it, gsub is the command that uses regular expressions to replace something in R. So I'll just add this regular expression commands in R. There's actually a whole suite more of them than that, but those are the ones that end up commonly being used. And so you can do this sort of search and replace and reformat data once you have it in R as well. It's not limited to just using this in the text there before you read it in something else like that. And honestly, most languages have some sort of implementation of regular expressions in the language symbol. Okay, so let's talk about these different wildcards that we can use, and we'll start talking about how we can end up using these. Okay, so the first wildcard is this, /W. Most of the wildcards that we're talking about are going to be some sort of / something, not all of them, but most of them. What /W will match is any alphanumeric character. So for instance, it will match A, B, C, all through Z, uppercase, lowercase, and then 0 through 9. It will match any of those. It won't match spaces, it won't match returns, it won't match periods, it won't match quotation marks, or anything else. It will match all of those. Well, not anything else. All of this it will match. And it will only match one. So if I put in a /W, it will match one of those. And so what we can do is we can use this multiple times. So if you imagine here, if we use \w, \w to search using regular expressions, we will match 3 alphanumeric characters in a row. Incidentally, if you use \uppercase W, so this is lowercase w, if you use \uppercase W, this will match anything that is not alphanumeric. So let me give you an example here. I have this convenient text file all set up here. It's basically the same basic thing that you saw before, except it's a little bit different. This has residence and state of the state, and then score and annual earnings. And I wish I could blow this up a little bit, but this one doesn't blow up. So what we can do is here, and this is JEdit. This is a text editor that is cross-platform. It works in all major operating systems, Linux, Windows, Mac. It's free. It's really nice and powerful. I'm going to be using this, and I've given you the download space to do that. As we're going through all the regular expression stuff, I would encourage you to grab this and use this as well, so that we're all in the same text editor, so it's easier for me to help you when you run the stuff. However, if you're pretty familiar with this and you have a text editor you really like, you can use that as well. I'll just warn you that there are a few different things that are slightly different. Implementation of regular expressions are slightly different between different operating systems and different text editors. This will keep it relatively standardized. Also, as you can hit Control F in here, it brings up the search and replace. And what we can do here is down here in settings, you want to make sure that regular expressions is checked. So we're actually using the regular expressions portion. Okay, so for instance, if I just do \w, 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 and hit find, it will match. It's really hard to see where it's matching. Let's start here. It will match. You can't quite see it, but it's matching right there, NAM. It's going to match a string of 3 alphanumeric characters. Search again, and it goes to the next. So one thing I'll mention is every time it does this, it goes to the whole next unique set. So for instance, the first time, can't see it, it highlighted NAM. When I hit find again, it did not go to AME, which is the next set of 3 alphanumeric characters in a string, but it's not unique. And so it goes to SEX. So it skips over the comma because, again, the comma is not alphanumeric. SLX, SEX. I hit it again. We select age. You can kind of see it. I need to figure this out at some point. Okay. If I did this like a bunch of times in a row, it goes to Minnesota because that's the next place, and then Christina, and then it goes to Kentucky. But that's weird because who wants to go to Kentucky? Okay. So that is the \W. Let's add in another one real fast. We also have \D. \D matches any digit. So it's actually a subset of the \W wildcard. It will only, however, match 1 or 0 through 9. Again, kind of like before, the \D matches anything but a digit. So this will match anything that is not numeric. So for instance, if I go back down here and say I want to have you get \W, \digit, it will only return things that have alphanumeric, comma, then followed by a digit. By the way, the comma is just going to be interpreted straight as a comma, like we're actually looking for an actual comma. That will be exact. So for instance here, it matches, first thing it matches, you can't see it everywhere, is 6, 5. Because wildcard does anything alphanumeric, it matches the 6, then the 5. If I go again, next thing it matches is down here, the male with the E, 6. So that's giving you an idea how we match patterns. We can actually match things that are, it doesn't match anything exactly, it's matching things that fit the pattern. Okay. Give you a couple more of these, and then we'll start doing things with them. Okay, \n or \r is a new line or a return. And usually, most operating systems or text editors will only recognize one or the other, but not both. In JEdit, \n is the wildcard that is recognized. And this is really useful for anchoring yourself to the very end or to the very beginning of a line. Imagine we want to get a string of 3 characters, but we want the first 3 characters in the line. We can begin it out with \n. So again, give you an example of this. If I go \n, \w, it will only grab, and right now it's highlighting the sh in Sean here, so it gets the beginning of the line sh. And if we keep going down, it'll keep matching. Now it's the JE in Jesse, now it's the CH in Charles, now it's the MA in Marion, so on. So we can use this \n is a really nice way to anchor the search to one particular end of the line. We do stuff at the, or I'll give you another example. We can go \d, \d, \n, and now it will only get things at the very end of the line. And so now it has the 67 right here. If I did it again, get this right here. Okay. Are there any questions with that so far? Okay. Let's add in another thing here. We can add pluses to the end of these wildcards. A plus will mean that matches any number of those from 1 to infinity. So a \w plus matches any string of alphanumeric characters from 1 to anything. \d plus matches any string of digits from 1 to anything. Okay, so let's go back down here again. Imagine I wanted to just get the name of all of these people. The name of each individual person. We know they all begin at the beginning of the line. I want to select the names. So for instance, I can do \n, \w plus, because I don't know, their names are going to be of variable length. So this will just match from one character to some, space, \w plus. So what this is telling it is the \n, say we're going to start at the beginning of the line, \w plus, then give us alphanumeric series of characters of any length from 1 to whatever. Give us a space, and then give me another alphanumeric character set of characters of any length. And so if we hit find, it gives us Penny Davis, and we go again, it's Nathan Vasquez, and then Vivian Chambers, and then George Mason, and on and on and on. And there's actually a slightly simpler way to do that, but that illustrates the point at this moment. Now imagine we want specific, like, okay, we don't want any number. We want, like, for instance, I only want match between 3 and 5 characters, or 7 to 10 characters. But I don't want to match anything that's less than 7 or anything that's more than 10 or something like that. Well, we can use, I flipped to the next slide and I'm on the wrong screen. What? No. Get over here. Okay. So imagine that I want to match an exact set of numbers. What I can do to get that is use the curly brace. Okay. Well, the squiggly brackets, I don't know. And this will match an exact number that we put into them. So for instance, \W and then the curly brace 3 will match a string of 3, exactly 3 alphanumeric characters. So this is the exact same thing as putting \W, \W, \W. That does the exact same thing. However, these curly braces give us a little bit more power than that. We can also put a comma in here, so we can do, for instance, 3, 5 will match anything in a range between 3 and 5. Or if we do 3, and then nothing after that, just a curly brace, we will get anything greater than 3. So this is kind of cool. This allows us to then set the number that we actually do this. And then one more principle, and this is where it becomes this is kind of what unlocks the real power of regular expressions. Well, one of them. I guess there's a lot of power of regular expressions other than this, but one of the things that makes it really nice is that we can then replace based on our search results. And we do that by using parentheses. In our search string, we put things that we want to essentially save for later replacement into parentheses. So if we put a pattern inside parentheses, then it'll save that search, then we can then use it in the replacement. And then when we make a replacement vector, or a replacement string, we can put those in there by doing either \, and a number, the number being which one of the order of parentheses it is, or in JEdit, a $1. So both of these can be used by different operating systems and different text editors. In JEdit is going to be $1. And again, the number corresponds to what we used in the search. So for instance, let's do this really simply. Imagine I wanted to do something to the effect of erasing all of this. I would use this, which is not anything to do with computing. And then imagine I wanted to match, again, 3 W's, right? Or not 3 W's, 3 alphanumeric characters. And I just want, there's 3 alphanumeric characters and I want to rearrange their order. Imagine I want them backwards. We can do parentheses around each of these. Now what happens now, okay, so this is now my search vector. This will return 3 alphanumeric characters in a row, and what it'll do is it'll save each of them essentially independently. This maps now to $1, this maps to $2, this maps to $3. So when I build a replacement vector, imagine I want 2, 1, then 3. My replacement vector would look like this: $2, $1, wait, 2, I don't know, 2, 1, 3, whatever. And what that would do is that would search for a string of 3 characters, and then flip the second and the first character around, and so we could change it like that. And so this would allow us then to reformat that however we want in that, and we could do this with 1,000 lines of data, 1,000,000 lines of data, and it'll all essentially be the same amount of time that you would have to put into it. Writing the search string, writing the replacement string, and then letting it go. Okay, let's take a look at something where we're going to actually use this. Imagine we have this, which is what I actually think I have in there, kind of. We have this data like this. We have name, sex, age, hire date, residence. Residence is their something, a score of something, and like their annual earnings. I don't know. I wonder if I'm breaking privacy laws by giving you annual earnings of fake people. Probably not. And what we want now is we want, again, kind of like what I illustrated in the beginning, we want it last name, comma, first name, not first name, last name, and in 2 different fields. So we want it to look like this. And that's basically what we have down here. And I want you to help me. How would we do that? Anyone have any, want to toss out any suggestions of how we would accomplish such a thing?
Go up to the first comma, take all the characters, until the first comma.
So, like that?
Yeah. That'd be the first step. And you also do the find a way of finding the second.
Okay. So what this will match, let's look at what that matches. I'm going to start up here at the beginning. W plus. Okay, so I search, gives me name. Actually, let's start here at the beginning of the actual stuff. Okay, it gives me Anthony. Wait, no, I didn't do the comma. So the first thing that it finds is Murphy, and then it matches male. That matches 33. That matches 2012. That matches Minnesota. That matches 1. So that might be a little bit overly general. How can we make this a little bit more specific? The other thing it does is it does get the last name here, parenthesis, comma, but because we're separated by a white space here, it doesn't grab the first name. Okay, space.
And then both of those in parentheses.
Okay.
Basis is going to be $2, $1.
Yeah, and replacement, $2, $. That's a backwards dollar. I don't even know how I make dollars backwards. $1. Okay. So, do you see anything up there that will also match this pattern?
The date.
Yes, the end of the date. So here we have December 2007.
Backslash n.
What's that?
Backslash n at the beginning.
Yep. So, yeah. So that will anchor it to the beginning. Can anyone think of any other ways that will get us now what we want? Okay. So let's do this. Let's try this. Are we set on trying this out? So we have backslash n, backslash w, okay, and parentheses backslash w plus, space, in parentheses backslash w plus. What's that? Oh, yeah. Do we? Well, I guess we're anchored. What do you guys think? Do we need the comma? No. Okay. And then, what do we want to replace this with? $2, $1. Okay. You ready? Cross your fingers. What happened? Does anyone think about what happened here? What's that?
You didn't say where it would take it like it.
No, it'll replace it in the same place that I found it from. Did you delete everything? Yeah, it's all on one line. Why do you think it's all on one line?
Placed on the backslash.
We did. We replaced all the backslash n's with nothing. We replaced all the returns with nothing. So let's try that out. Okay, Control Z is our friend here. Or just that. So we're back to normal. Okay, so let's try that. Backslash n. So that will hopefully not replace all of our returns now.
So is it going to replace the space too?
What's that? Yes, it will replace the space too. So everything that we capture here, we're only going to replace it with what we have in the replace. So if you were searching for something and getting something here, and you don't replace it here, you're not going to get it back.
So, one of the
Okay. Like that?
and space.
Add space? Okay. Anything else?
So what are we putting? What are the parentheses for that? Is that just to specify like?
The parentheses specify what goes in when this happens. So, but it doesn't specify only what you're replacing. Does that make sense?
Yeah.
Yeah. Because you can't do both of those simultaneously. I mean, they're closely related, but they're slightly different. Which means if you wanted to leave something out, you couldn't do it that way. Okay, so let's try this. Replace all. Hey, look at that. You think we need the space? Nah, probably not. One nice thing is you can just, whatever you do, you can undo real fast and then try again. How's that look? Hey, look at that. Good job.
How do we add column?
What's that?
Can we add last and first?
Yeah, and with column headings, it's usually just as easy to do that by hand because they're going to be slightly different. The pattern in the column, the column heading is going to be different than the pattern generally inside the data, and there's only one of them, so they're usually easy enough just to replace by hand. I mean, I could make a search and replace vector that only gets name itself and then replaces it with something, but that's basically exactly what I'm going to do by actually typing in and replacing it. So, good stuff. Okay, so another thing that's really nice about this is, okay, so we have this little set of wildcards I've introduced you to, and these are only kind of the beginning of the wildcards that you can use in regular expressions. But one nice one is that you can create your custom character sets if you want, and we use that by the square brackets. So we can use a square bracket, and anything that we put in here, it will become a custom character set that then will return one of that. So for instance, what I have up here is ATCG. This is actually one that gets used a lot. This will match any A, any T, any C, or any G, and nothing else, and only in capitals. And this is case sensitive, by the way. Everything in regular expressions is case sensitive. So this will return only the things that you find in the genetic code, which is kind of nice. We can only search for then, or only returns genetic sequences, especially if you make it sufficiently long. If it's just any A, T, C, or G individually, if we don't put, like, for instance, a plus on the end of this, so we have A, T, C, G, then that doesn't, if you just have one of them, that returns like almost anything, any A, T, C, or G. But if you put a plus on it, or if you put a minimum number, works out nicer. One nice thing, if you use A, T, C, G, and then curly braces 3, essentially that finds codons, which is kind of nice. And then also within in these custom character sets, you can set ranges, both for alpha and numeric characters. So for instance, if you add in A through Z, this gives you anything A through Z, A dash Z. If you get lowercase a dash, I don't know actually. I don't know. I've never tried. I don't know that you can, but I've never seen anyone use them. Does anyone else know by any chance? Just thought maybe someone would be. Okay. Alright. I don't know. We'd have to try at some point. But one thing that you can do is go like, if you wanted only something that was, you could go 5 through 9. And that will get you anything 5 through 9. The other nice thing is, I mean, so essentially if we wanted to recreate the dash W, yeah.
Or we can finish with that.
Okay. If you want to get anything that essentially replaces, if we go A through Z, little a through little z, and 0 through 9, this is exactly the equivalent of that. I'll just kind of give you, so you can append these back to back like that if you like. And that's what it sees. You don't need comments between these, it's just looking for those characters. Any questions? Yes?
So if you wanted to something like only pull out multiples of 2, can you do like mathematical operations?
I don't know. Again, I've never seen that happen, but I don't explicitly know that you can't. Let's try it. Why not? Let's explore this. I don't think so, because I think what's going to happen is if I do anything like greater than 2, it will look for the greater than sign and 2. Yeah, it's looking for 2's, 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 2's. Yeah. I don't think you can use mathematical operations in here. One nice one. There might be, okay, so there's a lot of regular expression wildcards out there. I don't know them all off the top of my head. And I use little cheat sheets to kind of like help me out. But one that I end up using a lot, because this one makes sense, and there might be a wildcard out there that does this, but I don't know about, is 0 through 9, period, because oftentimes you want the decimal place in there as well. Hey, we don't want to just get everything without the decimal place. Give me also the decimal place. Oh. The dot. The dot is crazy, because the dot returns everything except for a line break. And this is really useful if you're like, okay, I want to get this and this, and then everything else is garbage, I want to get rid of it. Then dot really helps out with that. So for instance, if I just wanted to return people's names and like the rest of it's just stupid and I want to get rid of it, well then, that helps. So for instance, dot plus gets you like everything into a line break. That's at least one character long. And there is one more. If you don't like plus, there's another extension that you can use. It's a little bit crazy, but it helps sometimes. Is the star? The star doesn't return 1 to infinity. The star returns 0 to infinity. So what that will return is, like, for instance, if I have a search string, and sometimes I might have a decimal number, but sometimes I don't, we can use 0 through 9 dot and then star. If it's there, it will return it, but it can also be 0. So if it's not there, it will essentially ignore that character set that we're looking for and go on to the next one. Does that make sense? So for instance, if we go back down here, imagine we had a case in which every once in a while, for whatever reason, this score column right here was empty. It just had a comma, nothing, and then a comma. But we still want to return our lines. We don't want to fail every time we reach those places. We can use something like this: 0 through 9 dot is a custom character set, and then star, that's 0 through whatever. It will return it if it's there, but if it's not, it'll say, okay, well 0 is okay, is an acceptable length to have this, and we can go on to the rest of the search place. Okay. Okay, so another practice. So we have this, we want to return this. I don't remember. Oh, here's a good one. Sex. Okay, so sex here we have female, male, female, male, female, male. And we want to return something else. We want to return just F or M because that is tighter. Then the other thing that we want to return is down here we have 19 June 2006. what we want is the first three letters, J-U-N, June, September, October, whatever. And then we want the 19 after that, and then we don't want 2006, 2004, we want 06, 04, all the way down. Is there anything else that we change? Okay. We want those things to happen now. How do we do that? And let's reset this back to what it was, because that's how the other one is. Yeah, it doesn't have the... Oh, no. Yeah, let's change everything, because the other one has... We have first, last, and we want last, first. Okay. So... And let me just do one thing here first. Hopefully this will make this a little bit more simple. I'm going to talk, before we come back to this practice, I want to talk about, oh, I flipped it and I didn't have it on the right thing. Real quick, a suggested workflow, and then we'll come back to it. One really nice way to set up your search strings is to do this. Go into a text editor and just copy down the actual line, like one of the lines that you want to actually end up replacing, searching and replacing, okay? And reformatting. Then the next thing is, around everything that you want to return, put parentheses around that. This is something that has worked well for me. So for instance, we want the first name here, we want the second, last name, comma, then we just want the first letter of the sex, and then we want the age, we want 19, then we want the first three letters of the month, we want the last 2 digits of the year. I think we dropped off whatever this is, so that wasn't there. We want the score, and we want this. Okay, so that's the first thing we do, replace it with that. Then the next thing is we go through and actually replace then what we find in here with the characters that will give us that. So for instance here, replace Patsy with \W plus, with Fletcher with \W plus, and then comma. The next one we replace, we only want the first letter of the sex, and so what we can do is we can do parentheses, \W here, \W plus afterwards. So this actually gives us a string of 1 plus some other number of characters after that, and we're only saving the first. We have a digit, comma, for the age, and then here we replace this with digit plus, and then for the month we go \W, but only the first 3 characters. But then there's going to be some amount of characters after that. No month is the full name is any less than 4 characters. So we have a \W plus, a space, and then a set of 4 letters, or 4 digits. 1 digit, 2 digits. And we only save the last 2 of that, \digit plus for whatever this is, but we don't save it, so we don't want it. And then, again, back here, we have in a custom character set, \digit. Oh, here's another thing. You can put wildcards into your custom brackets as well. So, for instance, instead of putting all this, I can just put \W and then the other characters that I want. So, for instance, here in this bracket, basically the same thing as this is \D period. So it gets me this whole thing plus the period, plus save those, comma. And then again in the brackets here, we have \D period, so that gets us the entire stretch of numbers plus the decimal point, plus, and then in brackets, or in parentheses. Does that make sense to everyone so far? And then what we do is then we figure out how we want to replace it. So the first thing then is, we want this, comma this, so we replace that, and then it's 3, 4, separated by commas because we want this, comma, so we got 3, 4, comma, comma. And then next we want to have this, and then this, so we want JUN, 19, and then this. So what we have is then we have 6, then 5, space, no comma, space here, and then a comma after the date, the reformat date, and then 8, and then 9. So let's go ahead, I'm just going to copy this in. Oh, Let me just take this. I'm going to copy that into there and make sure to show you how this would work. So we have that whole search string, and now if you look at that, that just looks like random characters up there. But it's a pattern that we can actually find the components of each line of data. Go back to our PowerPoint. Let's get the replace term. There we go. Go back down here. There we go. Cross your fingers. Replace all. Wait, find. Oh. Are you kidding me? What happened here? And then it comes to the troubleshooting, but there's only 1 minute left in class, and so. What did I do? Okay. If I had more than just like 1 minute, I would go through and troubleshoot this. Probably something simple, like I left out something or something didn't quite work right. For the moment, I'm not going to worry about it. Okay. There is an exercise up right now, an assessment on regular expressions up. That's up right now. Assessment 4 is up. So go ahead and go and grab that, and we will come back and talk about, or we won't talk about that. And there won't be a lab on regular expressions. Yes? Oh, no, there is not one for the second. Wait, is there one for the second lab? Yes, I think there is one for the second lab up. I think you put it up last night. But if not, I'll double check and put it up right now if it is enough. Okay. Okay, enjoy your weekend. I will see you on Monday.